Hello everybody and welcome back. So in this lesson we're going to now be talking about blocks. So what exactly is a block of code? So when we talk about a block, what we really mean is just basically a group of lines of code, right? So it's exactly what it sounds like. It's literally just a block or a chunk of code, right? And it has a little bit of a different syntax, which I've got a little example over here just to show you. So when we see here's an if statement, and then we see curly brackets, and normally it's tabbed in, right? This is the syntax for a block of code, right? So we'll work through it just now. We'll actually type it together so you'll learn the syntax properly, but just to sort of, just look out for the curly braces, and those will show you a block of code. So this line in here will only execute if this statement is true. Here we also have a for loop, so the if is inside of a for loop, and this entire block, see there's the start and end of the curly braces, so this entire chunk of code will execute with this for loop. So it's like we're grouping the lines of code together, attaching it to some sort of condition or a loop or something like that. Right. So this is what it looks like, just so you know what we're talking about. But let's delete all of this and start from scratch. Right. So one of the first loops we're gonna, blocks we're gonna talk about is an if, right? So an if statement is not a loop. It's just going to execute the statement once, right? But we're wanting to check a condition. So we're essentially just sort of setting some kind of, if this is true, then do the following, right? So the syntax for this is just to type if, and then you can put a space and brackets if you want to leave a little bit more space, or you can immediately just open your brackets. I prefer to leave a bit of a space. And then we just give it the condition. So this is a Boolean statement, so a 0 or a 1, false or true. And then if it's true, if this condition evaluates as true, then it's going to execute the statement. And now remember, this is running over points, so it's going to execute this whole wrangle, this whole snippet of code on every point. And our condition may be true on some points and false on others, right? Depending on what condition we set up, right? So just keep that in mind. That may be exactly what you want, or it may give you weird results because that's not what you want. Okay. So in this case, let's just set up something really simple. I'm going to say at frame greater than 10. Okay. So that's a really simple condition. So we end our brackets, and then we put curly braces to start the block. Now note that this entire line, nowhere is there a semicolon. I don't finish the line with a semicolon. I don't finish the condition with a semicolon. It's all just, this is opening one statement essentially. So we don't put a semicolon there. Then here we're going to type our block of code. So, whatever. And this will end up with a curly bracket. And at the end, we're going to put a curly bracket to close the block. Now note that I tabbed in here. You don't have to, but it's much better practice to do this. You can visually see that this is actually a whole block of code, right? And we're going to replace this because obviously block is not a statement. Let's do something. So let's say v at cd, so let's set our color to be equal to maybe, let's say 1 0 0. Okay, so that's 1 in the red channel, and then green and blue are 0, so it's essentially going to make it red. Okay, now you'll notice that nothing's happened because I'm on frame 1, but if I drag my slider to past frame 10, then our whole sphere turns red. And like I said, it's evaluating per point, but obviously the whole sphere is going to turn red because simultaneously for every point, the frame number is either above 10 or it's not. But if we did a different statement, maybe something to do with v at p dot y is greater than 0.5, now you'll see that some of them are above 0.5 in y, and then the rest are not. Okay, so that's a simple if statement. Now there is an additional statement that goes along with an if, and that is an else, because in this case we're checking this condition, and then if it's true we're executing something, if it's false we're just skipping it, we're doing nothing. And that's sometimes exactly what you want, but sometimes you want to choose between two conditions, to choose between two different blocks of code depending on the condition. So if it's true, then do this. If it's false, do something else, not just do nothing. So we type else, and then we leave a space, but you don't have to put any condition in round brackets, because it is attached to the same condition over here, right? As long as it follows an if. So we just open curly braces, and again you'll see there's no semicolon in this. We're just opening the block. I hit enter and tab in to write my statement here, and on the next line I'm going to close the block. Okay, so now here I can do something. So I could maybe say v at cd equals 0, 0, 1. Okay, so now I'll get, if the p y value is greater than 0.5, it'll be red. If it's not, it'll be blue, right? Now I know these two are kind of related, like we're turning one red and one blue, but you don't only have to do that. Remember, you can do anything you want in this entire block of code. So we could maybe add maybe not that much, 0.1 or something to that. So now it's going to make them blue and shift them upwards slightly. You can do anything you want in this entire block of code, and none of this will execute unless this condition is false, and none of this will execute unless this condition is true. Okay, so that's a simple if-else. Now let's clear this, and we're going to talk about while. So a while is a loop. Okay, so it's still a block of code, but while is going to apply the statement until the condition is false. So it's going to apply it and then check again, and if it's still true, it's going to loop and apply the block again and apply the block again until that statement, so the condition, changes to being false, right? Now you obviously just need to be very careful here. If you write a condition that will not change due to the block of code, then you're going to end up in an infinite loop. Okay, so if we had to say what we just said, if at frame greater than 10, right? Like right now, frame greater than 10 is true, and nothing inside the block is going to make the frame number change to being less than 10, so this block would execute infinitely. Okay, and then you're going to get a crash, or sometimes it'll be smart enough to error out and actually say to you, whoa, you've created an infinite loop. Okay, so you need to be very careful of that. Okay, so we're just going to say while v at p dot y, so we're going to say something similar to what we just did. We're going to check that while the y value of our points is less than, and then I'm going to actually create a threshold here, and I'll show you why just now. So we're going to just type a channel reference threshold. Okay, so while it's less than a certain amount, loop. Okay, and what we're going to do is add to the y position. So eventually it will be greater than this threshold, and therefore will be false and will exit the loop. Because even if a point is really, really low on y, if we just keep adding 0.1, 0.1, 0.1 and keep rising it up until it's until it's greater than this threshold and our condition becomes false. Okay, so here I'm going to just click this button over here to create the spare parameters. So now we have access to our threshold, right? So you see here I can drag the slider, and wherever it is, I'm setting a value that our points need to keep climbing until they are greater than. Okay, so you can see there, once it squashes up to the top, now it's essentially almost looks like we're just translating this up, but it's just because we're setting a higher threshold. Right. So that's a while. Now there's one important thing to notice with a while loop, is that it will not necessarily execute it at least once. So bear with me here. You see, if I have this threshold set below everything, okay, so nothing, this is immediately false on all points. You'll see that there's no difference here if I enable or disable the sphere, which means that it's checking this condition, saying, oh, it's false, so it skips the block. Almost like an if. It's just completely skipping this block because this is false. All right? Whereas we're going to do a different block function now, which is very much similar to a while loop, except that it executes at least once and then it checks the statement. So we're going to do something almost exactly the same here, just to compare the two. So I'm going to drop a different wrangle, plug it in. So the block function that we're going to use now is called a do, right? So this is similar to the while in that it's going to loop if until the condition is false. So if it's true, it's going to loop. If it's true, it's going to loop, and it's going to keep checking every time until it fails when it's false. But in this case, the statement, the block, is actually first, and then our condition is after the block. So you'll see we put do, and then we immediately open our block, and we jump into typing our block. So we say v at p dot y plus equals 0.1, exactly the same as we did on the while, because I'm going to show you the difference in the result. Okay, and then we close our block, and then after this we put our while statement. Okay, so we're essentially inserting our condition afterwards. It's quite easy to almost read this. It kind of makes sense. It says do this and then loop it while this is true. Okay, whereas on the while statement it says while this is true, loop the following. Okay, so the difference in the result is that this is going to execute at least once, even if our condition here is false immediately. All right, so let's just set that up. So we say v at p dot y less than and threshold, right? Which we will create the parameters for. Okay, and what I'm going to do is I'm actually going to link these two thresholds with a relative reference. And then I'm going to move my view back to here, but then template this one. Okay, so you can see what's happening, right? So this cage is showing the do loop, and the solid one is showing the while. Okay, now see when I push it up above, so all of the points are actually executing at least once, then it's identical. But as soon as we bring the threshold down to a point where some of the points, see all of the points below 0 are all executing this loop, okay? So they're ending up in the exact same position regardless of either of these two methods. But the rest of these are not, they are greater than, the y value is greater than the threshold, so immediately this statement is false, okay? So on the while loop, it's saying, check the statement, oh no, it's false, so don't do anything. So the block, these points on the solid sphere stay exactly where they were. Okay. On our do loop, however, it says, it takes the points as they are and moves them up by 0.1. And then it says, okay, do that again if the statement is true. But it checks it and says, okay, well, it's false. So it executed it only once. Right. So subtle difference, but important to understand because you will get a slightly different result. Okay. So now we're going to talk about a for loop. So a for loop is basically going to execute the block of code a certain number of times that we decide. And we decide that by using an index, okay? And then a change statement which increments that index, okay? So let me just type this so you guys can see this. So it's a for loop, right? And then in here we have an initial statement, then a condition to check, and then a change statement. Now don't type this. This is me. I'm just typing this out so you can kind of see visually what I'm talking about. And then we have a statement inside the block. So what this for loop is going to do is it's going to run this initialization statement first, just once, before it does anything else in this block. And normally we use this to basically create an index, okay? Then in the condition, it's going to check the condition. So this is exactly the same as the while loop. So it checks the condition, and if it's true, it will run the statement. And then if it's true, it'll run the statement, and it keeps doing that, okay? But after checking it's true and then running this statement, it runs this final statement over here before checking the condition again. So before re-entering the loop, it runs this change. So it does this once, and then it checks this, runs that, checks this, runs that. Okay, so that's how the loop is going to happen. So let's type this out. So in this case, I'm going to create an integer I, and I'm going to initialize it. So I'm going to give it a value of 0, which is my starting value for this. Now, we'll talk about this a little just now, but you'll see how if we initialize a variable in here, then it will not exist anywhere outside of this loop. It only lives within this loop, okay? And that's, for neatness sake, is very powerful because you don't want to override I if it's somewhere else or have it persist and then take up memory. You're just using it for this loop, okay? Then you can initialize it here. But if you do need it somewhere else, then you can actually initialize this before entering the loop. And then in the for loop, you would just reference I, okay? So then let's set up a condition. So our condition is going to be based on this index. So we're going to check if I is less than, and then we're going to take some kind of condition here. And what I want to do, because we're looping over points, is I want to take the point number, right? Because we're going to see how on point 0 this will not execute at all. On point 1 it's going to execute this statement once. On point 2 it's going to execute 2 times. Because I is equal to 0, it's then going to say, so let's say on point number 2, it says then, so is I less than 2? Yes, it is. So then run the statement, okay? So the statement will then be v at p dot y plus equals 0.1, like we've been doing up till now. And then it's going to execute this final change statement. And all we're going to do here is we're going to increment the I. So we just put I plus plus, okay? Now, what this does is it tells it, it's just a shorthand to tell it to increment. Essentially, I plus plus means I plus equals 1, okay? Or I equals I plus 1, okay? But it's much easier to just type I plus plus. So all it's going to do is add 1 to the I. And this means that every time we loop, I is increasing. Therefore, this statement is coming closer and closer to being false and will then stop occurring after that many times. And particularly if we feed it an integer starting at 0 and then whatever number, this would then essentially equate to the number of loops. So if we wanted to execute exactly 10 times, then we would feed it 10. and then all points would execute that exactly 10 times, and they would all move up by 1 unit because they move by 0.1 10 times. But in this case, we're going to feed it at ptnum, and you'll see that each point will execute a different number of times. Point 0 over here executes 0 times. It doesn't move at all. So it's not like the do loop where it occurs first. Instead, it occurs 0 times. On point 1, it's moved up by 0.1. Okay. You can even see in our geometry spreadsheet, if we look at our y, 0, 0.1, 0.2, 0.3. So it's essentially this times the point number. Okay. So that's a simple example to show you this, what a for loop can do. And I just want to show you this little gotcha. So this is what I was talking about before. If I wanted to, let's say, export this, so I at foo equals I, and I want to reference this index, okay, you're going to see that it's going to complain here that this doesn't exist. Okay, it's an undefined variable because this variable being created inside of a loop only lives within the loop. Okay, we'll do another example of that. So let's just create another variable inside here. Let's just say float maybe test equals 1. Okay, doesn't really matter. So it's going to set this to equal to 1. Okay, and then outside here, if I try and set foo to be equal to test, it's also going to say that this thing doesn't exist, because anything created inside of the block only lives within the block. Obviously, if we write to our variables, so our actual exported variables, then it will persist because these already live outside of this block. But variables created within will not. If a variable is created on the outside first, however, so if we say float test equals 0, and then in the block we just set test to be equal to 1, then this will work. Okay, because it does exist, therefore this knows what to reference, but this is just referencing that and adding into it. So it is exporting the data outside the block. Okay, exact same thing for this I, right? If we went back to referencing I, it's going to complain. But if here we sent int I equals 0, and then inside here we would just feed it I, then again this will work. Okay, we're setting it to 0, we're then pulling it into the block, incrementing it, and using it in our condition, and then right here we're exporting it, and you'll see that foo is equal to, and this is equal to 20 on this because it's incrementing it every single time. So it starts at 0, but then on point number 20 it's going to increment 20 times. Okay, so there we go, that's for loops. Now there's another type of a for loop, which is a for each. Okay, so I'm going to delete this. I'm going to go back to a sphere, and I'm just going to set up a little example. So we're just dropping that down. I'm going to use a wrangle to initialize an attribute. So I'm just going to say f at foo equals 0. Okay, and then I'm just going to paint some values here. Okay, so I'm going to override this with foo, and let's visualize it white to red. Okay, and wherever I've painted will be red. Okay, so I'm just painting a line of numbers. Okay, so that'll be equal to 1 there and 0 everywhere else. Now if we want to write a statement here where we essentially spread this value to all its neighbors, okay, so we're going to use a for each loop for this. So the for each loop, instead of feeding it a number, or essentially an integer like an index and then incrementing, okay, to reach a certain count, instead what we're doing is we're going to loop over an array. Okay, very similar to how a wrangle runs over points or primitives, vertices. Okay, this is like running a for each loop. For every point, so the points are almost an array of values. For every point, you're going to execute the statement. Okay, if there are 10 points, it'll execute 10 times. If there are 100, it'll do 100 times. Okay, whereas numbers here is like doing a for loop. It's run this statement exactly 10 times, regardless of how much geometry there is. Okay, so what we're going to do is we're going to run through an array of points. So we need to create an array, right? And we're going to use the neighbors function that we learned in the arrays lessons. So we're going to set up an integer, because we know we're storing point numbers, and we'll call it, we'll just call it near, and it's an array. Okay, so we need to put the square brackets after the name. Okay, and then we're going to run neighbors. Okay, and let's I'm just going to hit F1 on this so we can pop it up and follow this to fill in our arguments. Okay, so you'll see our neighbors function, all it needs is geometry and then a point number. So we're going to feed it 0 because we want to look on ourself, and then we're going to feed it at ptnum because we want every point to do this neighbors function. So every point here, so this point is now aware of its 4 neighbors. Okay, so it essentially has an array stored of every neighbor that it has. Okay, and then here we're going to do the for each. So you write for each, and just note that it is one word. Okay, and then we're going to feed it. So there are 2 different types of a for each, but I'm going to start with the simplest form. Okay, where we're going to feed it a value and then the array to loop over. Now the value that we feed it, this is similar to the index that we just used. It's basically a variable, but it's a variable where it's going to store the value of the current index in the array as we loop over it. Okay, so remember when we had an array, where if my array is equal to, and let's say we had 1, 2, 3, 4, right? Then it's going to loop 4 times, but when it does the first loop, the value of this variable that we're going to give it is going to be set to be equal to 1. So it's essentially extracting this item from the array and storing it in a variable for us to be able to use inside the loop, and then it's looping over the array the exact number of times equal to the length of the array. Okay, so you'll see what that does now. So because we know that our array is integers, our value should also be an integer, so we would say integer, and then you can feed it anything you want. It doesn't have to be I mean it can be anything. In this case it's our neighbors from our near, so I'm just going to call it n. Okay, or in fact let's do v, because this is kind of almost like a Python sort of a habit, is storing your value is v, your index is I, and your key would be k. So we'd say int v, and then here's we put a semicolon to separate these arguments. Okay, so there we feed it the v, and then we feed it the array. So we say near. Okay, remember we don't have to say near like with the square brackets, because once it's been initialized with a name, now we're just referencing that. Okay, and then we open our block. Okay, so right now nothing's going to happen because we obviously have no statement, but it's looping. Each point is looping 4 times. Well, if it has 4 neighbors, obviously the ones at this point will have a lot of neighbors. Okay, but most of the rest, because it's got squares, will have exactly 4 neighbors. Okay, and all we're going to do is check the because our value here v is the point number of our neighbor. So all we're going to do is go and set f at foo to be equal to the maximum okay, of two values. So its current value, okay, so at foo, and then the value of the point number that we're wanting to assess, so essentially the neighbor, okay, because so this point will have a 0 in at foo, but then it's going to check its first neighbor, which will also have a 0, so then it's going to set 0, but then it's going to loop to the next iteration. So it's going to check its next neighbor and say, okay, well, this is 0 and I'm 0, so I've still got a value of 0. And then it's going to go to its next neighbor and say, okay, oh, hang on, you've got a value of 1, I've got a value of 0, well, now I'm going to take that value of 1. Okay. And then when it goes to the next loop, because it finds a 0, see, we don't want to just set the neighbor's value to be equal to our value, because then we're just going to take that 0 on and become 0 again. Instead, we want to, that's why we're using the maximum function, okay? Essentially checking our own value and making sure that whichever one is the maximum we take. So we've got at foo, and then we're just going to take point, so because we need to access an attribute value from a particular point, so we can't just use at and reference it. We need to point to a specific point. So we're looking at 0, which is our first input, and then we're looking at foo, right? Because that's the value we want to, well, the attribute we want to grab, and then we say v, right? Because the point number, see here we would normally put like at ptnum if you want to reference ourselves. The point number we're wanting to grab is stored in v, which is coming from the neighbors function. Okay, so we've got that, and then we close this. Okay, now you'll see nothing here has really happened, but actually it has, because our foo values will have changed. Okay, it's just that our paint is actually what's visualizing this foo attribute. So let's just in here set v at cd to be equal to at foo. Okay, so now it'll be black where it's 0, white where it's 1, right? And you're going to see that that value has spread. So if I disable this function, this is exactly what we had before, a strip of values of 1 and all the neighbors are 0. Okay, and then when we run this, it now goes, so every neighbor that was touching an area that had 1 now has a value of 1. Okay, but all these other areas, see here, it ran through all of its neighbors. None of its neighbors had a value of 1, therefore it stays 0. Okay, so there's lots of ways to apply this, and a for loop and for each are very, very powerful, and then also the if you'll probably use most often. But just remember, this one runs over arrays, and then you can have access to that, the value of that element in the array. Now there is one more different type of a for each loop where you have its the index as well. All right, so if we say int I, okay, so you can feed it this optional first input, which is another variable where it's going to store the number of the loop essentially. So remember in an index, in an array, so I'm going to just type that again, my array, and then we've got, maybe just give it some different numbers, 4, 5, 6, 7, okay. In this array, this is index 0, but its value is 4. This is index 1, but its value is 5. So when we would loop over that array, the first time it loops, I is equal to 0, but v is equal to 5. Okay, and this would just help you keep track of, you know, some sort of count, or, you know, I mean, there's a lot you could do with it. Like, so maybe let's break out of this loop, because that's actually a bit of a segue into talking about how we can exit these blocks. So let me show you as a nice practical example. So let's use an if statement. okay, because now we know how to use that. And I'm going to check this I. So I'm going to say if I is greater than 2, okay, then, so here we're going to have our true statement, and then I'm just going to say break, okay. Now you see what happened there. Let me disable that, watch carefully. Right, so some of the values disappeared, okay. What's happening here, okay, was we're saying, okay, go run over this array, but actually after 2 iterations of this loop, just stop, okay. As soon as I is greater than 2, then just you're not allowed to do anything anymore, just exit the loop straight away, okay. So let's take one point at a time, right? So this point over here, okay, it assesses the neighbors. It has 4 neighbors, 1, 2, 3, 4, and it will run through them clockwise like that, okay. So the first time it enters this loop, I is equal to 0, and then it knows the point number of this neighbor. It checks its foo value and goes, you're 0, I'm 0, we're going to both stay 0, okay. It then goes to the second one, goes, okay, you're 0, I'm 0, right? I'm going to stay 0. Then it goes here, but it wants to check the next neighbor, but it goes, oh no, my index number is greater than 2, so actually I'm going to exit right here. So it stops. It doesn't run this function, okay? So a break function exits a loop as soon as it hits the word break, okay? Now, there's a few other statements we can use in terms of exiting loops or blocks in different ways. Break will just immediately exit, okay? Continue, if we say continue, it will stop, it'll exit here, but then, so it will not execute this line, but it will continue looping. So for example, if we had, when we had the break here, it will execute once, execute twice, and then break. So it will only have executed twice, and then the break happens and it just stops there. Even if the array was 100 in size, it would execute twice. If we say continue, then it will execute once, execute twice, then hit this point, skip this section and exit, but it exits not out of the block, but out into the next loop. So it would go to index 3 and index 4 and index 5. It just keeps skipping, so it'll skip here, and then when it comes back in, it'll check the statement again, and if the statement is still true, then it will continue. So it will exit, but it doesn't execute the entire loop, it just exits the iteration of this loop. Okay, so then if you have 100, like you're an array that's the size of 100, it will still loop 100 times. It's just that this function, this over here, after the continue, will not be run 100 times. It'll only be run whenever this is true. Okay, sorry, whenever this is false, so that it doesn't hit the continue. So then it will run this. Okay. And in this case, we're just saying if I is greater than 2. So as soon as it breaks, like as soon as it hits this point, this will never be false again. So the most efficient way is to use a break statement. But let's say this wasn't consistent. Maybe this was a if I don't know, we can do like a random function maybe. So we'd say I based on the random, and then you'd say greater than 0.5. So basically half the time this is going to break and half the time it will not, okay? But you see, in this case, we wouldn't want a break because it's going to randomly, it's kind of rolling the dice over here and going, okay, as I enter, I'm going to pick a random number based on my index and say, is it greater than 0.5 or not? If it's not, it'll run this function, but if it is, then it's just going to go whoop and just exit straight away. Okay, and it will not continue. It will not come back into this loop. It just stops completely, right? So if we put a continue here, then some of them will actually make it, right? Because even though maybe on the first loop, the first iteration, when I is equal to 0, then this rand value will be greater than 0.5, right? And then it will just skip. But maybe the next time it comes in, rand of 1 might return a value that's less than 0.5, and therefore it will skip over and run this statement, okay? So, big difference between a break and a continue. And then the last one we have is a return, okay? So, return can be used in two ways. So if I put a return function right here, then you'll see that nothing happens after this point. Everything after here is just ignored. The reason for this is because we're using it in the wrangle. We're essentially returning from the wrangle loop, okay, which is running almost like a function. So this is going to, similar to a break, is going to exit the whole wrangle. Okay, so we can, but again, it's sort of like a continue in this case, because like I explained in the beginning of our first classes when we were talking about this, the wrangle node will run over every single point. So even if you return, it will still continue to the next iteration, and then when it hits this return, it will then return again and exit to the next iteration. So it's actually more like a continue, okay? But when used inside of a user-defined function, so we're going to be talking about that soon, where we're going to create our own functions. So similar to here, now we're running this neighbors function and feeding it 2 arguments, and inside of here there's a whole bunch of code that's actually happening, processing the data we've given it to return a certain result. Well, inside of our user function, we can run a return, which is when we want to exit the function. And when we exit the function, we can exit it and give it an optional value, okay? Now in this case, in a wrangle, you don't return with a value. That this means nothing to a wrangle. But inside of a user function, what you would do is run the function, and then at the point where you're done running the function and you want to exit the function and store a value in whatever variable our user has fed, that's when you'll say return. So in other words, what's happening inside of this function is a whole bunch of code, and at the end it says return, and the value that it's returning is an array, and it's an array built off of this, okay? So then that's why it stores it in here. Whereas if it just at the end of that function had exactly what we said here, if I can type return, then it would be those, remember I've shown you those statements where it said that they were void, okay? So something like a resize function was void. If I hit F1, I'll show you again. So this was void, which means that inside of this function, it's actually saying just return. It's returning nothing. It got no actual value. It's just exiting the function. Okay, so I know the returns may seem a little confusing because we haven't done user functions yet. We will get there, so I will explain it again when we are doing our user functions, and you'll actually see how useful it is. But in your normal ifs and loops, like your for each, your for, your while, and do, you'll use continue or break, depending on whether you want to exit the loop entirely or whether you want to only exit the iteration and move to the next iteration in the loop. Okay. So these are blocks of code, right? This is what we can do with it. It's essentially just taking lines of code, grouping it together, and then putting it in separate little, whether it's a loop or under a condition, so that it will only execute if a certain statement is true or false. Okay. I hope that was pretty, easy enough to follow, at least. And as we start to use it, I think it'll become easier for you guys, okay? Sometimes the syntax can be a little bit difficult to remember, but once you use it a few times, then it really does sink in. Okay, so thanks very much for listening, guys, and I'll see you in the next lesson.